Okay, good morning, everyone. This is Thanh Nguyen with ASPEN, and with me today from ASPEN also there's another panelist, Suzanne, which will be talking to you about how you can automate the ASPEN OneLiner task using Python. I hope that the audio will be okay and you can hear me more or less clearly. If not, then I guess please enter something in the chat box or send an email to support@aspening.com. Okay, so the one thing I want to mention right away up front is this is what we expect that you will have. Those are the takeaway for you guys after you hear this webinar. Hopefully, after 45 minutes or an hour of this webinar, you will come away knowing that many of the ASPEN OneLiner tasks can be executed using Python scripts. And secondly, you will find out that it's not too complicated at all. Of course, any programming will be complicated by default, but you don't need a degree on computer science to do that. So that's the two takeaway that hopefully you guys can have from today. Now, so we'll have three main parts in this session: some introduction and the logistics of what's going on, and we will do demo on the different Python application so that you see exactly what's going on. And lastly, we will have some time for questions and answer. Okay, so hopefully you guys will have questions after you hear what and see what we have to show today. Again, yeah, so I'm Thanh Nguyen with ASPEN, and there's and also Su Zhang, another software engineer from ASPEN, will be presenting the material today. If you have questions, the best way to do it is to enter it in the GoToWebinar control panel under questions, and we will be myself and Sue will be watching it and hopefully we'll read it out and answer it to you. You can also call the ASPEN support number there on the screen and talk to Sue there. He can also direct the question to me when he is talking, and I can take the question too. You can also send a email message to support@aspening.com, but that may or may not go straight to us right away, so that we will answer to those questions, but they may be in a little bit delayed mode. Okay, so that's there also one more item before we go to our topic today. There's a couple of things I want to mention. That ASPEN had sent out the latest and greatest of the OneLiner version 15.5 to all the users who are current on the maintenance and entitled to those updates. If you have not received it, or you don't know whether you are supposed to be receiving it, just call us or email us. We will figure it out. Okay, so that's the latest of the version 15 with a lot of small and big fixes. So that's the latest and greatest that we have. Secondly, we have a formal OneLiner version 15 training web-based about 4 weeks from now, 2 or 3 weeks actually, and you can find out more about that on ASPEN website. Go to event page, and if you would like to further on today's topic. Also, there's a section in that training that will cover some of the stuff that we talked about today in more depth. Okay, so now Python and OneLiner. So I think I am assuming that you are here because and that means you are ASPEN OneLiner user, and you know that OneLiner is a graphic interface main focus, and you operate the program using the online diagram and mouse click on it and through menu and dialog box. So that's what we call GUI, graphic user interface mode. But then starting about more than 3 years ago with the version 14.8 and now official in beta mode and now officially in version 15, we ship with OneLiner a so-called OlxAPI module. So if you install the OneLiner, then you have version 15, then that module is on your computer ready. And what is that module supposed to do? It opens the OneLiner operation to other programs through so-called API, which stands for Application Programming Interface. That means OneLiner operation can now be executed not by hand using a mouse or the keyboard, but using another program. And that another program can be in Python to begin with, or in many other languages, C#, C++, and anything that can run on Windows. Any modern programming language running on Windows should be able to talk to OLX API module, and you can write a program in that language through this module to make OneLiner works the way you would like it to work, not through the keyboard. Click on the dialog box that ASPEN designed. Okay, so that's the difference. Now, next, if you want to work using the Python, then again, you are here because you are probably most likely a Python user. So if you know how to write Python script, then we ship with OneLiner also next to the OlxAPI module a set of library file that we created so that you can follow and use them to talk to the OlxAPI module and then operate OneLiner. So if you if you want to write one Python script, you will need to use this OlxAPI Python interface that we ship with OneLiner and to write your own script. And those scripts that use this Python interface to OlxAPI, let's from now on call it pyOlxAPI script. So that any Python script that use the OlxAPI interface to talk to OneLiner, let's call it py. And then we'll demo some of them today. Next, the Python interface is written for professional programmers. Okay, and it can make OneLiner. You can do all the API that OneLiner has, but probably you need to be quite proficient in Python in order to make use of that. Okay, so in fact, there are at least 2 or 3 professional software vendor who already took advantage of the OlxAPI module that we ship. They already created some commercial Python program that operate OneLiner to do additional study on the power network, like the relay calculation, relay setting calculation, and other thing. Now, but if you are starting with Python, then you probably will want to use the next library another library that we ship with OneLiner, and this one came out recently with the version 15.5. This is called pyOlx Objects. So this is an object-oriented library written in Python that you can reference, and we'll show you today later that with this Python library, it's very straightforward and almost no effort. You can do a lot of things with OneLiner API. Okay, so basically this library is designed to hide all the complexity that comes with the programming behind the scenes so that you can focus on writing the an application that you need, that you want to make OneLiner do. And lastly, all those script, of course, Python is a command line. Basically, you run it as a script outside in Windows. You don't need to start OneLiner to do that. But you can also, if your script is interacting with the if you want your script to interact, have some interaction with the OneLiner network that you have open in the GUI, and there's a way to do that. And we're not going to show that in depth today, but you will see how it can be done. Okay, so with those 4 items, starting with the module, which is generic, can be used for any language. And next, we should have the Python interface that specifically created for the Python to talk to OneLiner, and then the object library to make it easy to use. And lastly, there's a number of a special OneLiner action that will let you make your Python script to talk to the case that you are open in the GUI. Okay, so okay, so and I understand there's a problem with the audio, right? So if you can hear me, can you speak up and say whether or not there's a problem with audio?
Yes, everything's fine on my side, but I got an email from one of the listeners, so she said there is something wrong with the audio. The thing I can point out is on your control panel, there is something called the speakers. You may change the speakers to the one which makes a clear voice to you. So I'm not sure if you can find on that panel. That's the option you can have.
Okay, yeah. So so I'm glad that this is and at least some people, some of you, most of you can hear me. And yeah, so please try to do something at your end to see if you can hear me better. But so we have the recording of this, and again, also you can enter the question in the chat in the window. Okay, so I'll go to the next item here, which is the what you need, what kind of tool you need to have in order to run OlxAPI Python script. First of all, you need, if you can run ASPEN OneLiner on your computer, that's the first of all. You have to be able. That means you have to have OneLiner version 15 and a ASPEN license key. Okay. The license key can be local or network. And if it's network, then there's a special requirement further that you may need. You will find out later. Then you will want to have Python 3.7 or above. That's because the Python library that we write is more or less optimized for Python 3. It will also run in Python 2, but sometimes you will see some incompatibility there in some statements. So it's better to have Python 3. Now, this asterisk on the first line showing that if you use an ASPEN network key, then there is an extra setup step that you will need to put inside your Python folder for it to access the key. So I'm not going to go into detail here, but again, if you want to run the Python script with OneLiner with the network key, read the documentation to make sure that you set up the Python, which is just additional file that you have to copy to your Python folder. And to make it easy for all, if you want to get the Python that already all set up for the ASPEN, and there's a zip file on the ASPEN website. If you go to the website download page, you'll see that, and you can just download it and put it on your computer. And the last item is, if you intend to write something in Python, then it's advisable that you install some kind of integrated development environment to be able to view the output of your program and also to debug. But if you just want to run it, the first two items will suffice. Okay. Now this is a demo time. Okay, let me first I will demo in order a few and myself and Sue will demo a few OlxAPI script that we have written to at first as the demo so that you can follow and use that in your real programming if you need to do. But some of these are real application that do more or less hopefully some useful thing. So that's we use those. There are many of them, but we pick a few that hopefully will show in the broad way how through Python you can make OneLiner do something without running the OneLiner. Okay, so the first one I'm going to demo is a tool that we created called the font and differ, and this is a fancy font simulator that we use that you can that we want to use it to show you that with Python you can make OneLiner run the font calculation and get the result that you need. Okay, so here's um, the idea. If you have OneLiner on a GUI like this, and if you want to check how your relay at a certain location will be reaching out to a next line, for example, then one way to do that is to run a bunch of font simulation on this line, okay, and make it as a sliding font, and then you show the relay, say this phase relay, and then you can just show either one uh, result at a time, or you show it for all the font. Okay, but now this is nice and clean. But now, what if you want to have all those record as a report for other purposes? Then most likely you'll have to copy all those data out, and that is how you manually do it. But now you can make Python do it for you. And the way this script is designed is that it uh, uh, here's the Python script that okay, so I have to get to the folder here. We have a Python script called FLT diff tool, and what it's designed to do is it's designed to read in a input file that in Excel. Okay, and I will open it now, and that input file will have all the study configuration. Let me make it bigger. So in the Excel file in row and column, first you specified what is the file you want to open, what is the study branch you want it to be. So this bus name and KB, okay. So if I open again this file, you will see that bus Nevada to Rusen is the line I want to run it on. And next, you can specify this script will understand and read in the line what kind of fault you want to apply to this line. So those are some, in the first cell you say close in, and the next cell you say this keyword, intermediate with all the percentage. So Python is that Python tool is designed to read this file and then apply those fault here to also pick out the outage and apply the fault impedance. Okay, so this up to now is just you specified what fault you want to run on this file for in the input file, and then you specify what kind of output you want. So I say I want to monitor the relay group at Claytor to Nevada, which is this relay group. Okay, and inside that I want to monitor the relay of CLP1, which is this relay here. Okay, now and you can also this input also tell the Python program that you run this fault simulation with those outages as well. So this outage, the first one is Nevada to Arizona of the line, which is this line here. So now I'm going to close this one line. OneLiner is not running. Okay, and then I will just close. So this with this input, when I supply that to the that Python program that I'm going to demo, it will perform all of that and it will write out an output for me, which I'm going to show you. Okay, so let me close this input again also. Now this is the Python program. This is the file that it will take to operate on, and this is the input file that's going to be read in. Okay, so this Python program happened to have a graphic interface of itself. Okay, and if I double click on it to run it, here is the dialog box that have been uh, printed by that application, and it asks me what is the input file I want. Okay, this is already the correct one. If not, I just go and select the correct input file. So I'm using this one, which is what I show you. Remember, in this input file, it has a specification of what fault should be applied to that network inside. So when I say launch, this file will be read in. So Python is reading in that Excel. It will now read all the data in Excel, and then it will follow that instruction, which is it will load that OneLiner network. It will perform all the fault simulation and write out the result for that relay group and that relay. Okay, so I'm launching that program, that action now. The so this Python is doing this work, and okay, so it's asking me whether I want to review the branch outage. I say no, and okay, so there's the results already here, and it's that Python application itself automatically launch the Excel to open the output file for me. And the output file has additional pages. So the first page still has a repeat of what it read in. And also it has a list of all the fault that it has simulated. Okay. So you can see that because of the specification, I tell it to run first the close in and also the intermediate fault at 10%, 20, so on. So those are the fault that's simulated. And each one also have to be repeated with the outage of the line between Nevada and Arizona. So there are 20 faults that have been simulated. And here's the result that Python has written to this Excel sheet. Okay, so for each fault that we listed on the first page, for this relay group, we have a operating quantity, which is for the TOC, which is time over current element of this relay. And the 803 is the current that it took to operate, which is and that applies to the relay, and this is the time that is operate. Okay, and additionally, that Python application has been designed to print all the voltage and current that OneLiner found for that relay here. Okay, so you can see that without opening OneLiner, I was able to get a lot of information for the relay simulation and so on, and put it in a neat way, put it in an Excel. So that's how what Python can do for you. And this application also can go further. If you still run it, you can also supply that output file back here, but then you can, assuming that your input, your one line of case has been changed for some reason, then you can deploy that calculation will be repeated for all those forms, but now it will show what the difference is between the previous run and this run, assuming that your one-liner network has changed. So this is a kind of um, an operation that you can use Python to do to make one-liner doing. But so that's the first demo to show you that a Python script can have some kind of some graphic interface. It can read the data in, so that's a Python good in it. But then it can use the input from this file and make one-liner do something and write the output the way we want it. Okay. Okay, so that's the first demo. Let's see if there are any questions so far. No. Okay, next, the next demo I'm going to show you is having to do with this action here. Okay, here's another example network, very simplified. Uh, if you, I was running this fault simulation in this network, and there's something unusual, some kind of result that didn't make sense. So I went and go and check network anomalies, and I specifically looking for some very serious error, if there were any, so that to explain whether or not why my network is not solving. So this is the kind of a network model building error, where you have a loop with the back-to-back transformer Y delta, but they have different phase shifts, and one is leading, one is lagging, and so on. And if I check it with OneLiner, indeed I found one. This transformer between bus 4 and bus 6, which is this one. So if you see this loop here, so this one has the delta lag. That means the high side is lagging the low side. So you go from here, you will lag, right? But then you go this loop, and now this one has a delta lead. So this is an incorrect model building. So one of those should be flipped over to become lag. And of course, the standard that we have here in North America is the high side always have to lead the low side. That means this transformer has been entered wrong. The delta on the low side has to be lagging the high side. Okay, so this, with this one transformer, I can easily fix it this way. But of course, this is not a real system. This is a fictitious small system. I can see it right away. Imagine in the network of many thousands of buses, it will be very tedious to find out and fix that. So that's another application that Python can take over and do it for you. It can go and analyze the network the way you want and make the change you want to that you want. Okay. So now that had been done in another sample Python script. And so I can close this file now, so that I can to show you that OneLiner is not running. Okay, so this other Python script is here. It's another Python file. Okay, and this one I purposely chosen because it does not have any graphic interface that this one has. Okay, so for this one, you need to run it from the command line like that. Okay, so all you need to do is just type the name of that transformer connection. Okay, and if your computer already set up to run Python file, and this is all you need. I hit enter, and that tool is run. Wait, sorry. It ran only a moment ago. Yeah, I must have messed up something between my preparation and the database and now. So I'm not going to go and fix it again. But I just show you that. Oh, I guess. Okay, sorry. First, you have to run it and find out how to use it. Sorry. Okay. Okay, you run the command line with the Python file with the command. If it is an ASPEN made Python, usually -h will give you what the script is supposed to do. Okay, and this script is supposed to go around and find all the two winding transformer with wide delta connection, and if the high side is lacking the low side, it just flip the configuration to make it lead. Okay, and in order to run this script, you have to supply an argument of called -fi and give it a one-liner input file, and you give another input to give it in the output the corrected file. Okay, if there's anything it corrected, it will not going to save it back here in case you don't. So you always have the original. Okay, okay. So this here the command line that I ran earlier. You specify the Python script. So your computer has already set up to run Python, right? So you specify the input, and if the output is not provided, it will create a file with a special name. So I just run it now. I hit enter. It should be running, and this Python. Okay, let me put it aside a little bit first. Okay, let me put it aside first. The this Python script had opened this file using the OneLiner OlxAPI module. It's opened this file. It's found and fixed one transformer. It's exactly the one that between bus 4 and bus 5. And the modified network had been saved here. And it's also tried to launch this network for me directly. You see, that's why it was open. So remember that the original network is IE9, but then there's a W4 and now there's an RES into it. So this is the output. And you see that the transformer between bus 4 and bus 5 has already been flipped over. So this script actually then what it is open that file. It made all the changes once it's found, and it's saved the file back to another name. Okay, so that's the second demo. Now I'm going to do the third demo here. Let's close this. Okay, so this one is designed to show you that some interaction between OneLiner GUI, which is the one the file you open in OneLiner, and the Python OlxAPI script can be implemented. Okay, so now for that purpose, I'm going to run OneLiner version 15, which I don't have here. Let me go and run it. Oh, I think network and okay, so let me go and run OneLiner version 15 on my computer, and let me open that file previously I opened. Okay, so the task, I need to explain the background of this demo. Okay, so I was running this network to study a solar site here, and it didn't give me the kind of answer that I was expecting. It says shut down. Okay, so then the first thing I was investigating is that I found that this transformer seem to be incorrectly set up and so on. So I also, as a further check, I want to see if I can make a simplified network of just this portion, and then I don't have to care about all of those other things to see if my system is still running. So whether or not this model has to is correctly built as well. So Now that is mean that if I select this item where I want more or less the network is, then this demo will show you that there is a Python script that has been written that take the input as a line that I have selected and then run the network reduction command to produce a network equivalent for the network, eliminate all this around it and show the just the part that I need with that. So you can do that already with the network boundary equivalent, but this one has for if you want to run this one, you will have to select about all kind of bus here that you may or may not know whether they are directly related to this item. So this Python demo show you that there's a Python script that can be written to take the input of this line selection and use the API to call the boundary equivalent in the background and then reduce the network and open it for you. Okay, so that is the task. Okay, so let me try that. Okay, so I select this line so that and the goal is to reduce the network to just the item around it. So the you can start the so-called OlxAPI application dashboard in version 15, and that is how you can get the Python to be interacting with the Python script. You have to run it through this application dashboard, okay? And this is the script that I am talking about. In order for this script to show up in the dashboard, you have to point the dashboard to the folder where all those scripts are. Okay, in this case, I'm pointing to a default folder. After you run OneLiner installation, that folder will be there, and all those scripts that show here, I'm showing here will be there that you can run. Okay, so again, if I highlight this, then this button will let me launch it. So because I launch it from within OneLiner, then some interaction will be there. You see OneLiner is now pausing to wait for me to run some script, okay? And when I select this, it show me this script. This script is written so that it show the help screen each time you select that. And this help screens will explain a few things that first, in order, first it reduce a network to a smaller boundary equivalent. This is how it's designed, what it's designed to do. And secondly, it's take a few input. The first one is FI, which is what the input file it takes. So since we are running it from this inside OneLiner, we already have an input file here, and the manager already automatically put it here for me. So when I launch it, this will be this set of input will be used. Okay. So all I had to do is just say what is output I want to know. So this is the equivalent, for example, which is FO. It's explained here that you have to specify the output file. And next, you want to specify the, there's another option here that say what is the item select you want to select on the online diagram. Okay, and this item already filled out for me. It is a line between the bus 8 and bus 9. And there's another parameter called how many tier around that line you want to extra basically expand the network for the equivalent. So I just leave it a default one. I can put 0 or 2 or 3. And when I run it, then it will keep this line and just keep this line, and then this part will go away, will be equalized because this is one tier away from it, and this will be equalized as well. Okay, so let me just launch that application now. So this network is, this Python program is running in the background. It is showing me two things now. The first thing is showing me that the output file with the all the buses that have been retained based on the selection that I have. Okay, and secondly, it also create a network and it show me the equivalent network, and it's now showing it to me. Okay, so remember I entered that equivalent.olr. This is the file that I'm looking at now, as opposed to the file that was there. Okay, so this Python script finished running in the background, and then so I guess if I click any key to continue, then I have another. So I'm back to the original OneLiner, and this is a new file that was created, and this green color showing that this an equivalent path, and this is the remaining network that I want. So with this action, I was able to now have very simple network, just have my site and other equivalent source. And right away, I noticed that the equivalent connection between this bus and this bus is a phase shifter, which it only use only when there's some mismatch in the phase of those buses, and that confirmed me that that transformer connection that was there before is somehow is invalid. Okay, so that let me see if I can run that simulation here with again it's still shut down. That means, yeah, so that means if I had to fix this network. Okay, so that's to show that that's a background to show that there's a all kind of Python script that you can that you can write with the GUI, without the GUI, or you can run it from outside OneLiner, or most which is most often time you'll use that that way, but you can also run it from within OneLiner and taking advantage of the GUI, and the script can also will know what to do based on what you selected here. Okay. Okay, so that's the three typical demo that I want to show you. And next, I will pass the presenter token to Sue, who will explain to you, hopefully, in such a short time that he has, how straightforward or how effortless you can write some of those Python script. Okay, so Sue, if I can change the presenter to you, and now you can share your screen.
Okay. So can you see my screen clearly?
Yes, I can see your screen, and
Okay,
yeah.
I can, yeah, let me take open now. So this is Sue from ASPEN. Tan has showed you the OneLiner tasks can be executed using a Python script. And now I will give you an example of how to write a Python script of your own. First, I'm going to introduce you a sample Python script that is written based on OLX API library. And the script will execute the following functions: open an OLR file, locate the bus, network equipment, and relay, print network data and relay settings, update the network data and relay settings, then save the OLR file under a new name. With this sample script, you will find that writing a Python script with OLX API library is very straightforward. This is a py scripter, one of the IDEs that's available for the Python. There are many IDEs available, and we will use this py scripter in this webinar. But you may use other IDEs according to your preference. After you install the py scripter, you need to set up the Python versions. And here are the steps. Click Run, Python versions, and then set up Python versions here. You can add the folder where you store the Python and then add the path to this library here. One thing I need to point out that the Python and the py scripter needs to be 32 bits. Since the library we provide only support 32 bits. This is the sample script, and here is the header part. When you write your own Python script, you need to copy this to your file. But the two things you need to be customized. One is OLX path, which is the full path name of the folder where the OlxAPI.dll is located. Another is pyOlx path, which is a full path name of the folder where the OlxAPI.py and relevant libraries are located. You must customize these two path names to match your OneLiner installation. And the script won't run. Won't run if the path names are incorrect. This is the main function of the Python script. First, we assign the OLR file directory to fi. Then we call OLR case open to import the OLR file network data to OLR case. OLR case is a predefined network object in the library that you can use it directly in the script. If you type OLC case and dot, you will see all the methods and attributes that are defined inside of this object. Here we print out the OL case command and base MVA with this printer function. Let's put a breakpoint here. So here we can press this button or press key F5 to set up a breakpoint. Then we click this debug button, which is also we can call it F9 key to run to this step. And at the bottom part of the screen, you can see this file commands and system MV and base MVA are printed here. So now the OL case covers all the network data from the network. So if we are only interested in the area 1 with voltage level of 132 kV, so we can use method apply scope to update the scope of this OL case. With the input area equals to 1 and the kV range is from 132 kV to 132 kV. So after we call this method, the OL case will be updated. After we updated the scope of the OL case, we can view all the buses in the OL case with a for loop. Bus is an attribute inside of the OL case, and it is a list that covers all the buses within the scope. Let me put another breakpoint here, and then click debug. It will run to this step, and then we can step over. It will print. So the first bus within the scope is printed out. So the IT here stands for the bus object, and the toString will convert all the useful information of the bus to a string, and then we print it out. If we click this step over, you will see more buses are printed out. Then we set the breakpoint out of the for loop. It will print out all the buses which stays within area 1, and the bus and the voltage is at 132 kV. Then we apply the same thing to the line, which we use a for loop to loop through all the lines and print the line information. So we put another breakpoint here and make the program run to print out all the lines. So here are the list of the lines within the scope. Oh, another thing I forgot to point out. So here we call another method called the reset scope. So we call this a method to restore the scope of the one OL case. Since previously we use apply scope to make the scope limited to area 1 and voltage at 132 kV. Then after we call this, we use the reset scope to restore the scope, which now the OL case will cover all the network data. To locate a bus, instead of loop through all the buses, you could access the bus attribute of OL case directly from an index number. Here, B1 is the object, stands for the first bus in OL case bus attribute. We could also, let me see, put a breakpoint here, and then we run to this step. So the first bus is Alaska at 32 kV. Since we reset the scope, so now 33 kV is showing up here. We could also utilize the find bus method to locate the bus. So with the bus name and bus kV defined as input, we call the method find bus to locate the bus. To get more details about this OL case function, we can type in OL case dot find bus. So you can see now after I typing find, the find bus function already showing up, and it gives you the details how to run this function. And you can see instead of using bus name and kV, we can also use bus number, GUID, and a string to locate the bus. One thing I need to point out is for this GUID, which is a new attribute in OneLiner version 15, and it is the full name of this GUID is a global unique identification, which means all the network element inside of the OneLiner file, it will have its own unique ID, and we can use this unique ID to find the bus. Okay, let's keep running with this. So you can see with the find bus function method with bus name and kV, we find the bus Arizona, which is bus number 28 at 132 kV. And then here's what I just talked about, use the GUID to find the bus. Oh, I didn't. I put a breakpoint at the wrong. Didn't put a breakpoint, so it's run to the end of the file. So let me redo it. Okay, we come to the same step here. So then we use GUID to find the bus. Let's see whether we can find the bus. So we can find the bus successfully, and which means the GUID we given as the input is correct, and it's pointing to the same bus, Arizona. To locate a line, you can access the line attribute of the OL case directly through the index, or locate the bus, or we can locate the bus with the So we use the index, find the first bus within the OL case line attribute. The line is a Glean to Clater. Also, we can utilize this find bus method in OL case with we can use this find a line method to locate the line. This function requires the from bus object, to bus object, and the circuit ID. So we use find a bus two find a bus methods here to find the from bus object and the to bus object, then set them as input and to locate the line. So as you see, the line is found. We've printed the line information. It is from Clayton to Nevada. Instead of we can also access the bus object through the line, because you can see the line consists of some attribute like a from bus, bus 1, bus 2. So basically, bus is one of the attribute inside of the line. So we can access the bus through the line object. The same thing, we can access the line from the bus. So there are many lines connected. There maybe start from one bus, there are many lines, and we save those lines as an attribute inside of the bus object. And here L1 is the first bus, is the first line object that connected to the bus B1. So to access the line object data, we simply use L1.R to access the line resistance, and L1.X to access the line reactance. Then we can simply use this function to print out the line data. Now, the following case, we will update one of the bus name, and also we update one relay settings. So first, we find a bus with the bus name and the bus KV. Then we print out the bus information and print out the original name, which is so then we assign a new name to the bus. After here, we need to call the post data function. So this function, this method has to be called every time you finish all the updates of one object. Then you call this function to validate and update the object data. Then here is we access the first overcurrent phase relay inside of this OL case with the index 0. Then we print the relay information. We also print out the, here is something different about how to get the relay setting values. Originally from the line, we just use L1.R. Here we use another thing called RL.get setting with the setting name inside of the as the input. Then to update the settings, we need to use a method change settings to update the value. So originally the voltage polarized forward pickup value is 0. Now we change the setting to 0.3. And then we still call this post data function to validate and update the object data. And here's the updated value. After we done all these changes, we save the file, use olcase.save. This is the output directory, and we save the file to the save to the sample30.x.olr file. Then we close this OL case. Now let's go to the new file. So two things you can notice. One thing is this bus name of the Arizona becomes a new Arizona. Another is this overcurrent phase relay. The forward pickup, the voltage cross polarized. Forward pickup settings become 0.3. And this is all I have.
Okay, thank you, Sue. Let me go back and then claim the screen here. Okay. Okay, so you should see back my screen back here, right? So I want to conclude with this and the two things. Just a couple questions that you posted on the question list, asking why the PY manager in your installation is grayed out. So that's because there's some setup that need to be done for first. You have to go to tools and set up for where the Python folder is, so that OneLiner know where to use to find the Python. And secondly, you have to enter the path for the Python manager. I think this one may already be there automatically, but if not, you need to specify. This is one of the Python script that we ship with OneLiner version 15. So the idea is uh, you can write your own app manager if you want and just point the program there. And once you have those two things, then this app dashboard will be ready to run. So basically, when you select that Python application manager will be launched and with using the Python that you have. Okay, so that seems to be a common question here. The second, the next question and, is whether or not all of this material can be used and where the help material and so on. So this is the full set of resources that you can make use of. The this help file can be opened either in OneLiner or in on the web. And this here. Now ASPEN has provided a GitHub folder that's publicly accessible. Right after we finish this, most of the Python script that we are showing you and more already available there, they are more up-to-date version of the one that you have installed on your computer with the OneLiner installation. Okay, and right after this seminar webinar, we are going to post to that GitHub the sample that Sue is using today as well. Okay, just give us a little time, and then if you go to this folder, you will see it there. We also have a development mailing list set up. You can send this email to join, and you can exchange question with ASPEN support as well as other developer that using the OlxAPI library. And we also have the formal training classes for on OneLiner in general, and also for this programming with using OlxAPI as well. Now there will be one that's scheduled later in this summer, so you will send a notification by email. Okay, and I guess that we have all this material that we want to show you. And the time is a bit past 10, past 9 now. Let's see if there's any other questions. Well, as I said, there's a couple more detailed questions. We are going to send it back to you with the email then, because our time is up now. And I hope that you will be following us through all those the resources here, and also write to us as support, and we'll be very happy to assist you if you have any question and And we can even yes, in many cases on this ASPEN dev and so on, we can even show you the sample script that you would like to create, nice, and you can take over and finish it yourself. Okay, and thank you very much. And I will that would conclude the uh, presentation today. You will receive an email from us with the link to view the recording of this later on today when it's become available. And for those questions that I haven't been able to answer you, we'll email you with the answer. Okay. Okay. Thank you very much and have a nice day then.
Okay,
Bye-bye.
thank you.